Hi, so this is the PLC program for my mobile robot, which is programmed using a Siemens logo PLC. So when I explain programs, usually I start with the inputs and outputs. So I've got 5 inputs. I've got it in simulation mode at the moment, so I've got input 1 to 5. And I've also got one analog input, which I'll come to in a while. So input 1 starts the system. So this is input 1 here. And if I toggle it and allow the simulation to start. So if I press 1 and turn it off again, it will latch. So it will go through the normally closed input 2, through 1, then it would enable the internal flag, which would then turn the contact on the internal flag, and it will latch on. Input 2 is a spring return switch which stops the system, so that will just cut it off. So if I press off, it just turns it off straight away. So if I latch on again, that turns it on. Input 3 is an activation timer. So as the mobile robot goes around its circuit, the input 3 is a magnetic reed switch, which when it's activated, it stops the robot for 3 seconds, and that's I'm going to get to that in a bit after I've explained inputs 4 and 5. So inputs 4 and 5 are the infrared sensors that enable the mobile robot to move and steer. So if they're both on, the motors move forward. So each of these rungs enables it to go forward, turn right, or turn left. So when both sensors are active, you have M1 and M2 active, which means right-hand side motors forward and left-hand side motors forward. So that translates to enable Q1 and Q2 on the actual PLC. So these are physical outputs that will then switch the 12-volt relays on. So we've got right-hand side motors forward and left-hand side motors forward. So they're all 4 motors are going forward now. And as you can see here, these are interrupted by the timer. So if the timer's activated, it stops for the amount of time. So if you look T01 and T01, if that timer activates, it will stop the motors. Now if I just have sensor 1 active, we've now got turn right, which is right hand side motors forward and left hand side motors reverse. So this is Q1 and Q4 active. Then if I swap that round, so just 5, we've got right hand motors reverse, left hand side motors forward, and that translates to Q2 and Q3. Now what I'm going to do is make them both go forward and then activate the timer. This timer here, which I'll open up, is set to 3 seconds. So if I go down here, you'll see that at the moment we've got right hand side motor forward, left hand side motor forward. So if I activate the timer, they've both gone off, and they'll go off for 3 seconds, and now they've come back on again, and it would have passed over the sensor and come back on. This sensor also activates a counter. If I go down, so we've counted 1, so if I count again, it will stop the robot, and that counter on count 2 activates this timer here, which then makes the solenoid go. So if I do it again, nothing will happen because it's only counted to 1. So that's collected the ball, so it's under the ball depositor. Then if I count to 2, if you look at this, it will then activate the solenoid for 3 seconds. So 1, 2, 3, and off. So that's a solenoid that the robot then puts the ball into its location. So, and then when it's done that, it resets the count. So obviously, as it goes round the loop, it counts 1, 2, reset, 1, 2, reset. So on count 1, it collects a ball. On count 2, it delivers a ball. In addition to the actual functional inputs and outputs, we've got a safety. So we've got an analog input, which is analog input 1, which is actually input 7 on the actual PLC. And we've got this inputting into two special functions, which are analog functions. So we've got the sensor set to 0 to 10 volts, and this translates to a 0 to 1,000 measurement range, which on our system would be 0 to 10 volts. So obviously 100 is 1 volt. So as you get closer, the voltage goes up as you get closer to the ultrasonic. So what we've got, as you get to create a voltage of 5 volts, it creates a warning, and the warning goes off at 4.5 volts. So that activates the sounder on special function 2. And then special function 7, if you get even closer, which is 6 volts, that cuts the supply to the output relay. So that then shuts the robot down instantly, and you then have to move away for the robot to move again. So I'm just going to simulate that. So if I go down here, where is it? I'm looking for it. So if I get this range, so if I bring it up to, keep going. So now if you look, special function 7 is going up. If we keep going up, so at the moment it should just be ringing the sounder because we're at 562. Then if we get to 600, it will cut the motors off. So that's the motors off, and the robot won't be able to move again until we go down to 450. So I'm just going to tap that in. So we get below 450 and the robot's moving again. And I think that has covered everything. This timer here is also creating the pulse to operate the solenoid, which is on solenoid Q6. So I will just run through the whole sequence again as though it was running. So I'm going to stop everything. So press 1 to start, then 4 and 5, then we can turn left, turn right, and then we'll pulse once. Oops. Pulse once, which stops the robot briefly, which we've done. Then we'll pulse again, and that should activate the solenoid for 3 seconds. And that's gone past that. And then what we'll do is we'll go close and we'll do a safety, which has stopped everything. Everything stopped, and then we'll bring that back down, and you'll see these motors come on, and everything will eventually start again. And that's the simulation and an explanation of the PLC code. Thanks for watching.